So this is going to be a talk about design of security controls. And before we start anything, we always have to ask ourselves the first question: what problem are we actually solving? We don't ask this question enough when it comes to security. We kind of like spackle security on and say we're done. And some of it's a lack of knowledge of what to do and when to do it and how to apply it, and that's what we're going to address today. And some of it is just, security in general is just like everything else. It's a design problem. Everything you're building, your systems, the controls, they're all the same kind of thing. It's the same idea, and you should apply it across the board. You want to start with the problems and goals, just like everything else. What are you trying to actually accomplish? But most importantly is that you want to design specific controls that solve specific problems. We do that sometimes, like authentication. But on other times, we say, oh, yeah, well, we'll let somebody else deal with this, or let somebody else deal with that, and an alert or a monitor will go off, and it'll just kind of fall to the wayside. So as we add things, as we add layers, we're adding complexity. We're adding overhead, we're adding burden, we're adding stuff. So don't add stuff unless it actually makes a difference. This is true and true with security all the way through. You don't want to add anything that you're not going to be able to use down the road. And most importantly, good security design, the right security design, has layers. It has layers just like everything else you use. And we do this because we want to process things at the right place and at the right time. This is really, really, really important. Locality of reference. You may have hear this in mechanical sympathy or in large data processing. You want the data to be in the right spot at the right time. You don't want to have to go and get it or reprocess it or do it over again. You want to do the right checks at the right places. So we're going to talk about locality of reference a bit as it applies to how we add our layers and what we do and where we do it. We want to start with a wide net. And then as we get closer to the data, we want to add focus. Once we get all the way to the data, that's it, right? Like that's the biggest impact, and we'll talk about that too. It looks kind of like this, right? We cast a really wide net at the edge, and as we get all the way down to the middle, it's very, very specific, very fine-grained. It's down to authorization, things like that we'll cover later. We can break this down as it applies to Rails, and then kind of how we build a Rails app and the external components, right? At the very, very far edge, and not all of you will have this, but I'm talking kind of the larger situations as you start with the CDN. That's as far out as you get, right? The Akamais, the Cloudflares, that kind of environment. You can start all the way out there, and you can still do stuff there, right? And in fact, most of the CDNs will allow you to do security or have some controls all the way out of that edge, right? That's great. If you can do it there, it never even touches your application. You have things like the load balancer. What you do, how you deal with requests when they come in, how you route them. There's advantages to having that stuff as well. The web server itself, the proxy that goes back to your application. We have, of course, the application, but in our case, we're going to split the application into two places, especially with Rails. We're going to talk about Rack specifically, and then we're going to talk about the other stuff behind Rack. There's a critical component and a piece there you want to kind of think about and make sure you're doing the things in the right places as you divide this. And then, of course, what happens in the database later. Or you can collapse it. That's kind of the drawn-out piece. Right? It's kind of what happens at the edge, what happens at the application, and what happens to the database. People will laughingly call this a three-tier architecture. But really, those are the things we'll focus on. So depending on how you structured your application, we can condense it down into this. And I will say one thing is if you don't have an edge, right, if your application's running kind of on its own, that app server's running kind of naked in the internet, stop. Put the web server in. There's a whole bunch of stuff, there's a whole bunch of reasons why you want that, and we'll talk about that as well. And we want to act as far up the stack, as close to the edge as we possibly can. There's so much that happens before your application actually really processes the request. And you can take advantage of all those things that happen in between. And you can act on bad things way before they ever get to your application in certain situations. The closer you get to that data, the more damage something can do, right? If somebody's adding, they're trying to attack you, they're looking for something bad, if you hit them at the CDN, they never touch your app. But if you hit them at the very lowest layer of processing, they might get that SQL injection by, they might get that cross-site scripting attack out, right? So you want to keep stuff away from the data as long as you possibly can. So we'll start with the edge, and we'll kind of work our way through. This is where we actually want to do the heavy lifting. Most of the work we'll do in security will happen at the edge. When I say most, I mean the things that we can do without business logic. There's domain-specific things that apply to our business directly, but the basic security stuff that applies to everybody, we can do at the edge. Static configuration. Don't discount static configuration. This actually goes a long, long way. And we're going to have a bunch of checklists during this talk, and I'll publish the slides later so you can kind of look at it again. But I have a small set of static configuration things you should always be doing. These are just kind of the basics, and you should get them started right away. So the first is at least a B+ rating on SSL Labs. So this predicates the fact that you have SSL, or TLS running. So if you don't do that, you must. Pretty soon, Google has very audacious goals. They actually are starting to mark sites as insecure that are just HTTP only. Your page ranks go down. Even Chrome has a feature now that will bid you a big red warning if a site is not running SSL. So first of all, it's also free, by the way. There are services you can get certs for free. You don't have to pay for them anymore. There's no excuse not to do this at this point. So you want to set it up, but you also want to configure it properly. The B+ rating gives you kind of a nice sense that things are set up pretty well. You're not vulnerable to any of the known SSL attacks. You're running cipher suites that are kind of, they're recommended. There's no holes in them. Certificate chains are intact. You can see all the information about, who is the provider and where does it go. You're basically doing the right things. As you approach A and A+, you start to alienate users. There are older browsers that actually just can't even keep up with an A+ rating because the cipher suites are too new. So you want to kind of figure out who your user base is, where they're coming from, what browser they're using, and don't abandon them just for the sake of security. That's kind of unreasonable in some cases. So B+ is kind of like my go here, and if you go any higher, check and make sure you're not abandoning somebody by accident. Reject the extensions that don't apply to you. If you're running a Rails app and there's no reason to accept .php, just ignore it right up front, right? Just filter it. When those requests come in, reject them, right? If you're a .NET shop and .php, you filter ASPX through and you block .php or whatever your routing scheme is, whatever those extension types are, you reject everything that doesn't apply to you. Just put a list together. It's very simple, but you'd be surprised at how much you just kind of swat away in the process. Same with bad user agents. People publish lists. There's all kinds of bad user agents out there. Just put a list together, and whenever any of those comes in, just stop them. So I don't wait right at the very edge. You can do this at CDN, you can do it at the web server, you can do it at the load balancer. There's a whole bunch of places you can do this. But you can do it at the edge. The mod security project publishes a big known bad user data set, and just plug it in. I think some people have even shoved that into Nginx and Apache as like, here's the comp, here's the thing you copy and paste into your configuration. Rejects known bad actors. If there's an IP address that you know is bad, you can swat them away at the front too, not even let them through. And then custom error pages. So we don't do this often enough, right? When you have errors, you have a 404, you probably have a custom 404 page. You might even have a custom 500 page. But do you have a custom 403 page? When you say forbidden, do you have a custom page that goes along with that as well? Make sure you have that custom page. As soon as they see that 403, but it's the plain old generic 403, they go, I wonder what they're thinking here. They may start to dig a little bit deeper. Customize the error pages, make it look like you know what you're doing. And then basic secure headers. I have a whole bunch of references in the back on the slide deck that'll give you links out to all the stuff on like what headers are there to set, who will do what and when. There's a whole bunch of references. But these secure headers are things like HSTS, so HTTP Strict Transport Security, which says when you go to the website, it's always SSL. So the next time you come back, you can type in the domain, and you can try to type HTTP, but the browser won't let you. It'll force you to HTTPS. That's great. One of the things that happens, a nice kind of takeaway there is, let's say somebody has a link, and they've copied a link and pasted it out, and they hit it later, and that's an authenticated link. In some cases, you'd go to that link, and it might be HTTP, but it might have a cookie in there. And they might send the cookie over plain text. But if you have the HSTS header there, it's going to force it to HTTPS. So they won't leak that cookie over plain text. So things like that, it's protection for those kind of things. So great to have those kind of headers. Content sniffing, turning that kind of stuff off is great. The links I have will explain the attacks, explain the headers, why they're there. We don't have enough time to get into them all right now. But at the edge, you can also have dynamic controls, things that respond in kind to what's going on. Things like authentication caching. If you know your users, you know how they authenticate, you can have a cache there, and you don't want to have the app do a bunch of extra work, push it out. Push a cache out, and a lot of us do this anyways. Push the cache out up front and authenticate them out here. It might mean running a separate memcache instance or a separate Redis instance or something to keep that kind of in line, but you'll take the load off of your application. Now, this speaks to something, it speaks to availability, right? How many of you think availability is a security problem? All of you should be raising your hands. It is. Availability is absolutely a security problem. Sometimes you might think it's an operations thing. It is. It's also a security thing. If somebody can take you out because they hit you too hard, that's a security problem. And availability is absolutely critical to security. Web application firewalls. I have an asterisk here because I don't really like them. They're sometimes a little bit too finicky, and they require full-time maintenance and attention. But what they do is they stop patterns. They look for things like a script tag in a form, or they look for things like a SQL injection attack in a field, and they'll stop that request from coming through. So they basically give specific details, specific patterns. They match those, and they reject requests based on things they might know. Like I said, lots of false positives, pretty finicky. I like running them passively to tell me what's going on and kind of collect intelligence. At the same time, you got to be careful with these. Load shedding. So load balancers, edge controls, auto scaling, whatever you want to do, whatever you want to call it, things, Prolexic, Black Lotus, those kind of things, ways to shed traffic. When somebody hits you with a lot of traffic and they're trying to take you out, you want to be able to respond and get rid of that load. Identify it, isolate it, get rid of it. You've seen this a lot of times. I mean, unfortunately, GitHub gets hit with this quite a bit, actually. And they've improved over the years, and they're actually pretty good with dealing with it now. And they spend lots of time on that. But that's one of the things that I think we've all seen at some point. GitHub goes down, and you see, oh, yeah, it was a denial of service attack. And for some reason, people really don't like them, and I don't know why. But they've gotten the hang of this. But it will happen to you eventually if you get big enough and you make somebody mad enough. You might get a ransom note. Maybe you won't. But you want to be able to do load shedding, and you have to do it at the edge. Once it hits your application, there's no way. There's absolutely no way you can respond to it. Then there's Repsheet. Repsheet is an open source tool that I've written over the past few years that has a bunch of stuff around dynamic controls and kind of scaling out how you act and how you block people. There's a whole other set of talks online if you want to go see more about it, and I have a link to the project and the tools at the end of the talk. But that's enough about the edge. Now we'll talk about the application. But like I said before, we have two parts. And we can and should separate them, right? Rack comes first. The rest of Rails comes next. So there's a bunch of pre-processing stuff you can do in Rack before you really end up processing all the data in your application. So there's things like rack attack. Rack attack is something you may use if you don't want to do any of the throttling and IP banning and isolation at the edge. You can do it here. Rack attack lets you do that same kind of thing, but inside the rack, inside of Rack. You can have whitelists, you can have throttling, you can have blacklists. You can basically block people. Rack honeypot. It's basically bot detection. It'll push out some HTML snippets, things like that, identify bots, help you isolate them. Detecting Tor. Unless you have a reason to accept stuff out of Tor exit nodes, you probably don't want to. If you're running a commerce site where identity and anonymity are not possible because you're giving up credit card information, things like that, you don't want Tor. Tor exit nodes are all good, basically going to come from fraud. That's it. Now, if you actually want to support anonymity and privacy, then yeah, don't do this. Some sites absolutely want to keep that intact. But like I said, if you're on a commerce site, you want to block this stuff because it usually means fraud. Warden is really authentication-based stuff. Rack throttle. Kind of a throwback to rack attack, but allows you to throttle requests if somebody sends too much at once. I don't recommend doing this here. I recommend doing it out further. There's better tools with throttling, and they handle it better. The bucketing and some of the throttling techniques that Nginx and the CDNs have are much more advanced and scalable and work a little bit better than this. But if you absolutely have to do it here, you can. And Rack Cylon is actually kind of a really important one. It's for indexing. So it makes sure that indexers only hit your site when you're actually in production. Sometimes you have QA sites that are live, they're exposed to the internet, and then the search engine goes and crawls it and then pushes out the new thing you were about to release and didn't tell anybody about yet because it was on your QA site. You're like, oh, crap, it got leaked, right? So you don't want the really aggressive search engine indexing to go grab stuff you don't want out yet. So Rack Cylon makes sure that you're only in production will it allow crawling to happen. It will basically empty everything out and disallow robots until you flip that switch and you're in that right environment. So it's kind of silly, it's kind of small, but it's actually really important if you want to keep things secret, especially with public QA sites. And then custom stuff, right? You might write custom things to handle certain pieces, to ask certain questions about the requests. I know that that's things I do all the time. It's business-specific things. I might want to check something before it comes in. I may have a tricky user or two trying to do something, so I might put some logging or monitoring in there. You can kind of add whatever you want here. But the point is, this is before it hits the meat. So you want to try to do that up front. So Rack does the heavy lifting. But the context, the line here is that this is for checks that don't require additional data, right? Stuff that's in the database. Once you hit that point, once you actually need that piece, that's what the application does, right? So there's stuff that Rails is going to offer, right? There's a ton of built-ins. Rails actually has a ton of really good stuff by default. It does a lot of good stuff for you. Lots of great security stuff built in. It even does secure headers very well. The headers that I talked about before, Rails will put out for you in most cases. And you can tweak them and change them and modify them however you'd like to. But the default set is actually really good. So look at the Rails built-ins. I have a bunch of links to guides and that kind of stuff that detail what Rails does. But you should go check it out. There's a bunch of really great stuff that's done for you. Authorization. This is the kind of thing that you want to do in the application. Authorization is very, very important. Who can see what can they do, that kind of stuff. That really is dependent on the application. You need that logic. You need business logic there. And you're going to need a database to figure out who's got what permissions. Authorization is something that happens in the stack. Encryption. Again, asterisk. You may do that elsewhere. You may do that in HSM. You may do it in Amazon's KMS system. You may do it off in a different site. You may do it with a different tool. If you're going to do encryption, this is probably the place to do it. You're going to do it in context with what you're storing, how you're storing it, maybe a field, maybe a row, maybe a table. But you'll want to think about encryption here if you want to keep stuff safe. And then domain-specific stuff, right? This is stuff that applies to your business. You're a Snowflake. What are the things that affect you specifically? Fraud, in particular. How does fraud work for your company if you're doing any kind of commerce? Specific business rules, things that people might take advantage of, things that you think are one way and maybe not another way, maybe not tested properly. And last, what you really want to think of as a proper SDLC. You want to have security baked into the lifecycle of how you write software. How many of you have security as, it's in your CI, it's basically like you see it when you write code. How many of you see security as you're developing? All right, everybody look around for a minute. Huge problem, right? Huge problem. Doing it in these places saves you a lot of time down the road, a lot of headaches. Software security has to play a major role in how we build stuff. You have to put this kind of front and center. Now, yes, all the controls I just talked about don't apply to general software security. The stuff at the edge is configuration, operations. The stuff at the application layer absolutely is. And you have to have solid programming practices. That's the core of all this. Once they get past all the controls, all the stuff at the edge, all the stuff in rack, down to the application, now your code. That's it. The last line of defense is your code. You have to have good principles and practices there too. Every phase of development needs to have that. The stuff in between has to have it. CI, it's a great thing. If you have a test suite, add security checks to it too. In fact, I have a whole checklist of things you want in your build. Tests. I'm not talking about TDD, but tests. Tests, right? Test the important stuff. Some notion of what you tested, right? Whether that's code coverage or something, right? Some kind of thing that tells you, here's what I have tests for. And you want to look at that and say, hey, what are the critical components of my system? You should make sure there's tests for those, right? I'm not advocating 100% code coverage. I think it's completely insane. But you want to have coverage around the things that really matter to you. Metrics. This might seem silly for security, but it is. It's great. Metrics tell you where you have your worst code. And in your worst code is usually your worst bugs. And where there are bugs are probably security holes too, right? That really, really nasty, complicated class or method that's this big and knocks you over when you look at it and has really flaky tests because you really can't get it all right, there's probably something nasty hiding in there. So you want to find that stuff and use those metrics to help you fish out things that may even be also security bugs, right? Cleanly factored code helps you reduce complexity, helps you get rid of security issues. It's all just good principles and good design. Brakeman. Brakeman is a Rails-specific static analysis tool that looks for security issues. If you don't have it yet, grab it. It's a gem. Just type Brakeman and it'll give you a big report. Awesome tool. Very easy to use, very easy to hook into CI. Awesome, awesome, awesome tool. Bundler audit. So it's not just the code you write. It's also the code that everybody writes. Your gem file lock is probably enormous, or just staggering in some cases. Every single one of those lines in your gem file lock is potentially a problem. You want to make sure that it's safe. The versions that you have locked should be secure. And if there's known issues, Bundler Audit will tell you, hey, this version isn't secure. You should update it. And you can also look at the CVE, see if it affects you. You don't have to update it just because Bundler Audit says you do, but you should look at it and see if it actually affects you. So Bundler Audit is something you can run in your build as well. It'll flag it. It'll fail a build and say, oh, you got dependencies that just don't match. You want to update those. So maybe it's something you don't do every time you run rake, but maybe it's something you do before you go to production. Right? There's phases. A bundle audit's really important as well. Those dependencies can absolutely kill you. Last is data stores. What do we do with the databases? I get really grumpy about this. This is just like every single person in this room probably has a lot of work to do here. This is where we kind of leave everything behind. Because the database is running, and we get our data, and we don't think about anything else. So a lot of times, we just ignore what we should do to keep the data safe in the database. Here's a checklist, and this will maybe turn some heads. The first one, not so much, right? Never use the root user. Just don't. You should never use the root user for anything except for setting up the other users. Once it's done, throw the password away, but put it somewhere safe and only give a couple people access to it. Nobody needs that password. Nobody should be using anything as the root user. Strongly and securely store your production passwords. No, do not check them into Git. That's a really bad idea. Your entire development team does not have to have the production password. It's not a good idea, right? It is not that you don't want to trust everybody, right? It's not that. Mistakes can happen. It's really easy to make a mistake and maybe run your test suite against a live environment by accident because you had the wrong password. You really want to make sure that those production credentials are kept in production and stored safely. You want separate users for runtime migrations. How many of you have the same user that you use for migrations and booting up your app? Raise your hands, it's fine. Yeah, don't, right? Your running app doesn't need to be able to change the schema and drop tables and do all that crazy stuff. It doesn't matter. You don't want that. You want separate users. Run your migrations in a separate way and run your app in a separate way. It's really about permissions, right? Your app should only have the permissions it absolutely has to have to do the job it needs to. Take away everything else. Because basically what you're doing is if somebody gets in, somebody finds an angle on your database, then they have whatever permissions that user has. So take away the stuff that doesn't matter. Separate databases. Don't put everything in one database. It sounds silly, but people do it all the time, right? Staging, tests, production should all be separate. Yes, it can be a pain to copy and make sure you have reasonable-ish production data in your testing and staging environments. It sucks. But don't put it all in one place. You're bound to make mistakes. Also, the things you do in your test environment will probably need more permissions as well. Right? Tests will always need to set up tables. Tests will always need to do certain things you would never need to do in production. So your test environment will have more permissions anyways. And also, you might just be doing weird test stuff. So separate all this stuff. Firewalls. Firewall all this stuff off. Your database should never be open to the internet. Ever. For anything. Unless that's what you're going for. That's what you're trying to serve. If you're a database company serving online databases, then yeah, sure. But otherwise, firewall that thing off. And really only let the apps that need access have access. Just put it all down. There should be a really strict allow-only firewall that says, here are the applications that are allowed. If you're on Amazon, security groups, right? If you tag these things in these security groups, you're the people who allow access, that's it. They can go up and down, you can change instances, but you're all fine. Logs. Log all this stuff. And maintain the logs. Rotate them, back them up, archive them. Keep the logs. You want to know what happened if something bad happens. And then back it all up. Back up your database. I mean, again, availability is part of security. If you can't go back up because you deleted your database, you can't come back up, and now that's an issue. It's a loss to your company. But do backups and do multiple backups. Do backups of critical data, the things you absolutely need to run, the small set. Do it every hour. And you can back up all the things, and that's a daily backup or a weekly backup or however you want to do it, right? But back things up. And then stuff in between. Everything in between you need to look at, right? Monitoring, auditing, logging is all critical. You have to be doing this stuff and looking at it to see what's going on in between. And if anything bad happens, you want to know, you want to see a trail, right? You'll thank yourself when things go south. Not just for security, but also for operations and postmortems and root cause. That kind of stuff is important. You want to have the audit trails, and you want to have the data. And the last thing is focus. Security is not something you do when you can, right? That's usually what happens. I mean, there are lots of, I'm sure there's companies in here who have dedicated security teams. I know there are, right? But it's not something you do when you have time or when you get to it. You want to have focus. Whether or not you know a ton about security, you'll learn it. I promise you'll learn it. It's much easier to teach somebody who writes software to do security than it is to teach somebody who does security to write software. You guys have everything you need. You know how to do this. It's just a matter of getting resources and context. Focus. Doing it halfway is just going to lull you into a full sense of security. You're going to think, oh, I did some stuff. I'm probably pretty good. And then you're going to get blindsided one day, right? Because you didn't have the right kind of focus. This doesn't apply to everybody in this room. Not everybody has something super critical in production. Do it when you need to, right? If you have a static site and there's not much to take away, cool, have fun, right? But if you're doing something critical, if you're storing people's data, financials, health records, that kind of thing, you owe it to those people to keep it safe. And you need to focus on that kind of thing. And the last thing is that eventually, it's all going to come crumbling down because that's how the internet works. But I have some references. Like I said, I will make those available online sometime later today. And then these are basic links, things like SSL Labs, how you run the test on your site, security headers that are important, the Repsheet project, the full list of the rack middleware that I listed. I picked out some, but there's the full list here. The Ruby on Rails security guide, the official one, the OWASP Ruby on Rails cheat sheet, which is a bunch more information, and then the Brakeman website as well. And there's other links in there that are kind of buried in the talk. You can Google them pretty quickly. But these are the really important ones to take away. Thank you.